Hello everyone, today I am going to discuss about index of greatest power IGP. IGP here stands for index of greatest power. Okay, first of all, what is IGP? Any idea? What do you mean by IGP? Okay, look here. Suppose I will say in 10 factorial, IGP of 3 is how much? In 10 factorial, IGP of 3. Basically, that means how many 3's are there in 10 factorial? 10 factorial, it can be written as what? Now, this is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So, how many 3's are there? This is 1. 6 can be written as, if I do prime factorization, this is 3 into 2. And here 9 is what? 3 into 3. So basically, how many 3's are there in 10 factorial? You can say, sir, IGP of 3 in 10 factorial is 4 times. Or this also can be represented as in this way, 3 to the power 4. When 3 is present 4 times. So basically, what is IGP? Now, highest power of any number in a given factorial or a expression. So here factorial is given 10 factorial. So in 10 factorial, IGP of 3, index of greatest power of 3, highest power of 3 in 10 factorial is what? That is 4. I mean basically in layman language, how many 3's are there in a given factorial? In 10 factorial. But if I will say in 100 factorial, suppose number is given, n is given 100 factorial. For 100 factorial, how to find IGP of 2, IGP of 3, how to find? 10 factorial is a small number. Manually you can write and count. But for bigger factorial, how to find? Let's say for 100 factorial. And question is, IGP of 2 is how much? IGP of 2 in 100 factorial, it is how much? Now the process is, for a prime number, you just keep on dividing the number by, here divisor is 2. By 2. So if I divide by 2, my quotient here is what? 50. This is quotient 1. Again 50 is divided by 2. I will get 25. This is quotient number 2. And in this method, now leave the remainder. Leave the remainder, only concentrate on quotient. Again 25 by 2, 12 is the quotient and 1 is the remainder. Just leave the remainder, only concentrate on the quotient. 12 by 2, I will get 6, again 6 by 2, I will get 3, 3 by 2, I will get 1. Understood now? And remainder is what? 1, just discard this one, leave this one. Now if I add all the quotient, 75, 87, 93 plus 3, 96 plus 1, 97. The IGP of 2 here is 97 times. IGP of 2 in 100 factorial, it is 97 times, or this can be written as 2 to the power 97. So how many 2's are there? 97 2's are there. So this is IGP. IGP of 2 in 100 factorial. Similarly, let's say IGP of 3 in 100 factorial. Again 100 by 3, 33, 33 by 3, 11, 11 by 3. That is 3, remainder 2, leave. Then 3 by 3, 1. If I count, here I represent 100 divided by 3, 33, 33 by 3. I will get quotient is 11, 11 by 3, 3, 2 is the remainder, that discard the remainder. Now 3 by 3, I will get 1. If I add, how much I will get? 44 plus 4, 48 times. Or this can be written as 3 to the power 48. Similarly, IGP of 5 here is IGP of 5. First we will discuss about all the prime numbers 2, 3, 5, 7. Then we will discuss about the composite number. So for 5, what I will do? Again 100 by 5. 100 divided by 5. I will get quotient is 20. Again 20 by 5. I will get 4. If I add, how much I will get? 24 times. or this can be written as 5 to the power 24. Similarly, IGP of 7, 100 by 7, 14 into 7 is what? 98. So again 14 by 7, it is 2. So 16 times. IGP of 7 in 100 factorial. This is 16 times, or you can write 7 to the power 16. 7 to the power 16. Similarly, now we will discuss about composite numbers. Let's say composite number is 8. For 8, how to find? For 10, how to find? What is IGP of 8 here? IGP of 8, IGP of 10, yeah, 15. Okay, these are what? Composite numbers. So first I will discuss about 8. IGP of 2 in 100 factorial is how much? 97 times. That means what? Now here I can write 2 into 2 into 2 into 2. How many times? 97 times. Now here I need 8. If I make a pair, this pair will give me 1 8. This pair will give me 1 8. Similarly, another pair, 3 2s are there. This will give me another 8. Similarly, how many such pair possible? Total 2 available, 97. How many 8 possible? What is IGP of 8? So 97 pairs are there. 97 2s are there. So if 3 2 make one pair, the total how many such pair possible? Now 97 by 3. 97 by 3 I will write 32. 32 times. This is 8 to the power 32. Then 1 2 left, that's just a discard. Because we need another 2. 2 2s, okay, to make 1 8. Now IGP of 10. How to find for 10? If I do prime factorization for 10, it can be written as 2 into 5. Now how many 2s are there? In 100 factorial, already done 97 times. 2 into 2 into 2, 97 times. And how many 5s are there in 100 factorial? How many 5s are there? 24 times. Now if I make a pair, this pair will give me 110. This pair will give me another 10. This pair will give me another 10. So total how many such pair possible? Total 24 such pair possible. Achha, here how many factors are there? Prime factor 2 and 5. Bigger prime factor is 5. So here 5 will decide my answer. Understood na? The 5 will decide my answer. So 5 is dominating. So you do prime factorization, always bigger factor will decide my answer. If you compare 2, obviously 2 present more number of times. In any factorial, 2 can be present more number of times. Okay, compared to the bigger factorial. So here between 2 prime factor, 2 and 5, 5 will decide my answer. So here I will write how many 10s are there? 24 times, or you can write 10 to the power 24. And important is IGP of 10, it is also called number of trailing zeros. IGP of 10, the other name is called number of trailing zeros. I will discuss this one by one. What is trailing zero? So what exactly this trailing zero means? What do you mean by number of trailing zero? What is trailing zero? So let us first try to understand what is trailing zero. Normally trailing zero means number of zeros at the end of any expression or factorial. Suppose I will say 1000. 1 0 0 0. Understood? How many zeros are there at the end? 3 zeros are there. So number of trailing zero means number of zeros at the end of any factorial or any expression. Then, so now I am going to discuss about this trailing zero. So look here. If I will, here who will decide my answer? When the question is about IGP of 10 or number of trailing zero, find number of trailing zero, who will decide my answer? Here 5 will decide my answer. So can I say this statement like this, ki number of trailing zeros in any factorial, this is nothing but IGP of 5. Number of trailing zeros, it is nothing but IGP of 5. Can I say this statement like this? Number of trailing 0. Who will decide my answer? 5 will decide my answer. 10. If you do prime factorization, 2 into 5, that is 10. So obviously in any factorial, if you compare 2 and 5, 2 present more number of times compared to 5. So here 5 will decide my answer, because you have to make pair 1 2 and 1 5 in a single pair. That will give me 1 0, that is 10. Similarly, how many such pair possible? The minimum value will give me the answer, and for bigger factor we will get minimum value. So here I can say number of trailing zeros, that is equal to IGP of 5. Now we will solve few questions based on this number of trailing zeros. So example number 1 or question number 1, you can say, suppose I will say find the number of trailing zeros in the following question. Beta E 1142 factorial into 348 factorial into 7 factorial. B double I 1 factorial into 2 factorial into 3 factorial up to 30 factorial. Find number of trailing zeros. Bit triple I, first 50 multiples of 5. 50 multiples of 5 means 5, 10, 15, like this. And the last one is 250. Find the number of trailing zeros. And you know number of trailing zero means IGP of 5. So bit number I. Acha, first element is 1142 factorial. Acha, factorial, number of trailing zero means what? IGP of 5. So how many 5s are there? For a prime number, for 5, you just keep on dividing the number by 5 unless and until the quotient is less than 5. So if I divided by 5, 5 into 2, 10, 14, again 5 into 2, 10, 4, 2, 5 into 8, 40. Remainder 2, discard the remainder. Leave the remainder, okay? Only concentrate on quotient. Now this number divided by 5, 5 into 4, 20, 5 into 5, 25, remainder 3. Again divide by 5, I will get 9. Again divide by 5, 5 into 1, 5, 4 is the remainder, leave. Now if I add all these quotient, how many quotients are there? 4. If I add, how much I will get? This is 10, 15, 23. Carry 2. 6 to 8, and this is 2. 283 times. How many 5s are there? In 1142 factorial, IGP of 5 in 1142 factorial. Here IGP of 5 is how much? IGP of 5, that is 283 times. Now for 348 factorial, just keep on dividing 348 by 5. 5 into 6, 30, then 4, 8, 5 into 9, 45. Again divide by 5, 5 into 1, 5 into 3. Now no need to write the remainder, okay? Only concentrate on quotient. Again divide by 5, I will get how much? 2. So if I add, how much I will get? 11, 3, 14, 4, carry 1. And this is 8, 7 plus 1, 8. So here I will write IGP of 5 in 348 factorial. This is equal to how much? This is 11, okay, plus 3, 14, 4 carry 1, 84. 84 times. Similarly in 7 factorial, 7 by 5, it is 1, 2 is the remainder, leave. So here I will get 1. So final answer for this question is what? Now this is 283 times, then for 84 times, then 1. So this is equal to, this is 8, okay, then 12 to carry 1.
Hello, this is 6. 368. Unit place 3 plus 4 plus 1, this is 8. Then tens place, this is 8 plus 8, 16. 6 carry 1, then 3. So 368.
1 factorial to 30 factorial it is given. Okay, and basically again you find how many 5s are there. Acha, to solve this one, with double I, make 3 column. In column 1 you write factorials. In column 2 you write number of trailing zeros in each factorial. And column 3 you write total. So make 3 column. Now 1 factorial to 4 factorial. You choose any number according to your convenience. Suppose I choose 4 factorial. Normally 4 factorial means what? 24. 5 is not the factor of 24. So here in 4 factorial how many 5s are there? 0. Or the process is what? You just divide the number by 5. This is not possible, na? So here each factorial has a 0 trailing 0. So total is 0. Now 5 factorial to 9 factorial. You choose any number. Suppose I choose 6 factorial. Now 6 by 5. Quotient is 1. Remainder 1. Leave the remainder. So here each factorial has how many trailing 0? Each factorial has 1 trailing 0. Total how many numbers are there? How many factorials are there? 5. Because 5 to 9. 9 minus 5, 4 plus 1. 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. 5 factorial means total is what? 5. Now 10 factorial to 14 factorial. Choose any factorial. Suppose I choose 12 factorial. Now 12 by 5, 2. Remainder 2 leave. So total is how much? 10. 15 factorial to 19 factorial. If I choose 15 factorial, each factorial is what? How many trailing 0? 3. Total is 15. Similarly 20 factorial to 24 factorial. Choose any number. I choose suppose 20. 20 by 5, 4. Quotient is 4. So here 4. Total is 20. If I select 25 factorial to 29 factorial. Suppose I select 25. Don't write this is 0, 1, 2, 3, 4, then 5. No, wrong. You choose any one factorial. Suppose 25 factorial. 25 by 5 is what? 5. Quotient is 5. Again 5 by 5, you will get 1. If you add, how much you will get? 6. Each factorial has 6 trailing 0. Total how many factorials are there? 5. 5 into 6, 30. Then, question is up to 30 factorial. It may vary. Maybe it is up to 50 factorial, 45 factorial. So be focused, be careful. So if I will say 30 factorial here, 30 by 5, 6, 6 by 5, 1. So here 7. So total is how much? If I add 15, 30, 50, 80 plus 7, 87. So number of trailing 0 is 87 times. Number of trailing 0 here is 87 times. It is visible that side. 1 second. I will check. Okay, done. So here number of trailing 0 is 87 times. Clear? Write it down. Now beat 3. It is very easy. This one done, understood? Okay. Now this is 5 into 10 into 15 up to 250. Okay. That means first 50 multiples of 5. Achha, from here I will take 1 5. From here I will take another 5. If I will take 1 5, I just pull out 1 5. So what is there? Remaining element is 2. Again I pull 5. 3 is present here. So total how many 5 I can take outside? Now 50. So here I can write 5 to the power 50. It is not visible here. Okay, here I will solve question number 3. Just focus here. Here this can be written as 5 to the power 50. I take 55 outside. 5 into 5 into 5, 50 times. So this is 5 to the power 50. And inside the bracket what I will write? 1 into 2 into 3 into 4 up to 50. 1 into 2 into 3 up to what? Up to 50. Done. Clear? Now this is 5 to the power 50. and this one is what, 50 factorial. 1 into 2 into 3 up to 50 means 50 factorial. And in factorial, how to find IGP of 5, you know. Why I am finding IGP of 5? Once again, number of trailing 0 means what? Number of trailing 0 means IGP of 5. So in 50 factorial, how many 5s are there? Just keep on dividing. This is a 10. Again divide by 5. I will get 2. If I will add, how much I will get? 12. So this is 5 present 50 times. So answer for this question is 50 plus 12. That is 62 times. So number of trailing 0 here is how much? Number of trailing 0 is 62 times. Number of trailing 0 for this one, for this question, and 5 is multiplied 50 number of times. Okay, that means first 50 multiples of 5. Okay, sorry, first 50 multiples of time. 5 is not multiplied 50 number of times. Here the question is first 50 multiples of 5, and here number of trailing 0 is what? 62. 62. So these are the examples. If you understand, now I am going to solve the questions. Clear? Any doubt? As before we will start the question, another key concept. Okay, what is skipping 0? What do you mean by skipping 0 concept? This much done. Why skipping 0? Because if you observe here, for 24 factorial, number of trailing 0 is 4. But when I write 25 factorial, number of trailing 0 is 6. Suppose the question is, tell me the value of n for which n has, or n factorial has 5 trailing zeros, and 5 number of trailing zeros. The answer is no such factorial exists. So that value is skipped. For 24 factorial, you have 4 number of trailing zeros. For 25 factorial, you have 6 number of trailing zeros. So in between no factorial exists, na, integer value. So if the question is, tell me the number which have 5 number of trailing zeros, tell me the factorial which has 5 trailing zeros, that is no such factorial exists. So that value is skipped. So now I am going to discuss about skipping 0. Skipping 0 concept in I.G.P. Okay, everything clear? Okay, good. So give heading concept of skipping zeros. Acha, write down one quiz. Find the minimum value of k for which no factorial has k, k plus 1 or k plus 2 skipping zeros. No factorial has this much skipping zeros. No factorial has how many? Now 3 consecutive skipping zeros. Okay, and 3 consecutive skipping zeros are there. Now 3 zeros are skipped. 3 zeros are skipped. Done. So tell me the factorial between which factorial to which factorial 3 zeros are skipped. No factorial has this much trailing zeros, not the skipping zeros, this much trailing zeros, k plus 1 or k plus 2 trailing zeros. That means these are nothing but the skipped value. These are the skipped zeros. How to find this? So already done that. I make 3 column there in the previous question. Okay, and there we observe in 24 factorial number of trailing zero is how much? This is equal to 4 times. Okay, so whatever the value 24 factorial, this is how many zeros are there at the end? 4 zeros are there. And when I will write 25 factorial, number of trailing zero is how much? Already done in the previous question. We make 3 column there. In first column we write the factorial, second column number of trailing zero in each factorial, third total. Okay, and here how many trailing zeros are there in 25 factorial? It is 6. Just keep on dividing 25 by 5, 5. 5 by 5, 1. So total quotient is how much? 6. So in between how many zeros are skipped? 1 zero is skipped. And that skipped value, it is denoted by k. And here which value is skipped? Now 5 is skipped. This is example number 1. Observational, okay? At the end I will give you the observation. Example number 2. If you observe 124 factorial and 125 factorial, you just find number of trailing zero here. Number of trailing zeros in 124 factorial. Just keep on dividing 124 by 5. 5 into 2, 10, 24, 5 into 4, 24. 5 into 4, 20, 4 is the remainder, leave. Again by 5, 5 into 4, 20. 4 is the remainder, leave. If I add, how much I will get? 28 times. And in 125 factorial, number of trailing zero is how much? Now keep on dividing 125 by 5. This is 25, 25 by 5, 5, again 5 by 5, I will get 1. If I add, how much I will get? 31 times. Now the observation is, in between how many zeros are skipped? 2 zeros are skipped. 2 zeros are skipped here. And these values are what? Now k is equal to 29, k plus 1 is equal to 30. So 2 values are skipped here. But in this question, how many zeros are skipped? K, k plus 1 and k plus 2. Means 3 consecutive numbers are skipped. So example number 3 you can say, or observation number 3. Achha, if you observe here, 25 means what? Now 5 square. So here 2 minus 1 zeros are skipped. 1 zero is skipped. 125 factorial means what? 5 cube. Here power is 3. 3 minus 1, 2. So 2 zeros are skipped here. Similarly, in this pattern, if you understand the pattern, then 5 to the power 4, that is 625. So between 624 factorial to 625 factorial, 3 zeros are skipped. So just you find the number of trailing zeros in 624 factorial and the number of trailing zeros in 625 factorial. So for 624, divided by 5, 5 into 1, 12, 5 into 2, 24, this is 4. Concentrate on the quotient. Okay, now you understand the question, understand the thought process. Okay, we only concentrate on the quotient. Again, if I divide by 5, 5 into 2, 10. Now 24, 5 into 4, 20. 4 is the remainder, leave. Again divide by 5, I will get 4. 4 is the remainder, leave. Now if I add, how much I will get? 48 plus 4, 52. So 152 times. Sorry, here 624. 152 times. Now in 625 factorial, 625 by 5, 125. Again 125 by 5, I will get 25. Again 25 by 5, I will get 5. Again 5 by 5, I will get 1. So 150, 55 plus 1, 156. 156. Done. So this is 156 times. Achha, in between how many zeros are skipped? Now here k is equal to 153. 3 zeros are skipped. K plus 1, this is 154. And k plus 2, this is 155. In between 3 zeros are skipped. And what is the minimum value? Minimum value here is 153. So answer for this question is 153. 153. Minimum value of k. Question is find the minimum value of k. Minimum value is what? 153. Understood the pattern? Once again, skipping 0. 3 observations are there. I give 3 example. You can say in one, between 24 factorial to 25 factorial. How many zeros are skipped? 1 zero skipped. How you know? Because 25 means what? 5 the square. So power minus 1 zeros are skipped. Similarly, example 2, 124 factorial to 125 factorial. In between, how many zeros are skipped? 2 zeros are skipped. This is 5 cube, power 3 minus 1. So 2 zeros are skipped. Between 624 factorial to 625 factorial, how many zeros are skipped? 3 zeros are skipped. This is 5 to the power 4, 625 factorial. 5 to the power 4, power is 4, 4 minus 1, 3. So 3 zeros are skipped. Done? And minimum value is k minimum is 153. Understood? Take this screenshot or write it down. Take this screenshot or write it down. Important question. This is the concept of skipping zeros. Okay? Okay. Okay, next question. Find the maximum value of n such that 157 factorial is perfectly divisible by let's say 12 to the power n. 157 factorial, it is perfectly divisible by 12 to the power n. As 12 to the power n, 12 can be written as what? 4 into 3, 2 square into 3. Done. So now 12 to the power n. So this number to the power n, question is find the maximum value of n. So in 157 factorial, how many 2's are there? What is I.G.P of 2 in 157 factorial? If I divide by 2, this is 7. So 14. 1, 7. This is 8. 1 is the remainder, leave. Again divide by 2. This is how much? 39. Again divide by 2. This is 19. Remainder is 1, leave. Again divide by 2. This is 9. Again by 2. This is 4. By 2 I will get 2. 2 by 2 I will get 1. So I.G.P of 2 in 157 factorial. So this is how much? 9, 8, okay, this is 18, 18, 8, 26, 26, 9, 35, 4, 39 and 3, 42, carry 4. So this is 11, 10, 14, 115, 152 times. Now here 2 square means 4. What is I.G.P of 4 here? I.G.P of 4 in 157 factorial. How to make 4? How many 2's are there? 2 is present 152 times. Now this pair will give me 1 4. So how many such pair possible? Now 152 by 2. So this is 76 times. Done? Clear? Now, how many 3's are there in 157 factorial? I.G.P of 3 in 157 factorial. Now just keep on dividing the number by 3. 157 divided by 3, this is 5 and this is 2. 1 is the remainder, leave. Again divide by 3, 3 into 1, then 22, so 7, 21. Again divide by 3, I will get 5. Again divide by 3, I will get 1. So this is 9, 14, 1, 15, 5 carry 1, and this is 7, 75 times. So in 157 factorial, 4 present how many times? 4 present 76 times, and 3 present how many times? 75 times. So what is the maximum value of n here? Maximum value you can say 75. Maximum value 75. So answer for this question is 75. Here answer for this question 75. Minimum value will give me the answer. Okay. So answer here is 75. Write it down. Okay, noted, or take this screenshot. Clear? Again similar question, next bit. Take a pause, try it, and then see the answer. Again, question number 2 you can say, or the quiz. Find exactly similar question, maximum value of n such that 50 factorial is completely divisible by or perfectly divisible by 12600 to the power n. Find the answer here. So options are given. Take a pause, try it. Okay. Now, first of all, I do prime factorization of 12,600. If I do prime factorization, if I divide the number by 2, the smallest prime number, even prime number. So this is 6300. Again this number divided by 3, I will get 2100. Again by 7. So 7 into 3, 2100. Again by 3, I will get 100. Again the number divided by 5, this is 20. Again divided by 5, I will get 4. Divided by 2, I will get 2. So here 12600. It can be written as how many 2's are there? 1, 2, 3. So this is 2 cube. How many 3's are there here? 3 square into how many 5? 2 into 7. Done. So this is the prime factorization of 12,600. Now here power is n, 12,600 to the power n. Question is find the maximum value of n. Then here in this number 50 factorial is perfectly divisible na? So 50 factorial. In 50 factorial, if you observe, number of 2 cube and number of 3 square will not decide my answer. Why? Because in 50 factorial, if you observe 2 and 3, 2 cube and 3 square, the number of 2 cubes and number of 3 squares, they can be present more number of times compared to 7. Because 7 for in 50 factorial, how many 7 are there? And I.G.P of 7 is what? Now 7 into 7 49. 1 is the remainder leave. Again 7 by 7 1. So 7 is present 8 number of times. Done. But 2 cube and 3 square, it is present more number of times. We can cross check it. Okay. Suppose I will find the value here. How many 8 are present in 50 factorial? 50 by 2, this is 25. 25 by 2, I will get 12. 1 is the remainder leave. Again by 2, I will get 6. Again by 2, I will get 3. Again by 2, I will get 1. 1 is the remainder. So this is how much? 37, 43, 46 plus 1, 47 times. So in 50 factorial, I.G.P of 2 is what? I.G.P of 2, this is equal to 47 times. If I.G.P of 2 is 47, the 2 cube means 8 is how much? I.G.P of 8. IGP of 8 in 50 factorial na, divided by 3. If I divide by 3, I will get 3 into 1, 17. So this is 5, 15 times. 2 is the remainder, leave. So how many 8 are present? Mane 2 cube are present 15 number of times. 7 present, how many 7 present in 50 factorial? This is 8 times. So this will not decide my answer. And 2 will not decide my answer. Similarly, if you check for 3, in fact 50 factorial, what is IGP of 3? You just count IGP of 3. And just counting, na? It's all about counting. Just keep on dividing. And be careful when you do the division, otherwise you can do the silly mistake. So divide by 3, 3 into 1, 20, 3 into 6, 18, 2 is the remainder, leave. Again by 3, 3 into 5, again by 3, I will get 1. So how much I will get here? 21 plus 1, 22 times. Now 3 square, 9. So IGP of 3 square. 3 square means just divide the number by 2, I will get 11 times. 3 present 11 times. So again this will not decide my answer. Now important is you have to find IGP of 7 and IGP of 5. In 50 factorial, IGP of 7 is what? IGP of 7. Now 50 divided by 7, I will get 7, 1 is the remainder, leave. Again divide by 7, I will get 1. So 8 times. IGP of 7 is 8 times. 7 present 8 times. Now how many 5s are there? Because 5 is the one of the factor of 12600. So in 50 factorial, what is IGP of 5? Now 50 by 5, this is 10. Again by 5, I will get 2. So 12. The 5 present 12 times. And how many 5 square is present? 25. IGP of 5 square here is 6 times. So here minimum value is what? The minimum value is 6 if you compare, because here n depends upon 7 and 5 square. How many 7 are there? 8 times. And how many 25 are there? 6 times. So when I make the pair, the minimum value always give me the answer. And the minimum value is what? 6. So answer for this question is 6. Understood the thought process? Okay, note it down. Then we will discuss the next question. Okay, complete? Okay, next question is IGP of 5. You can say if IGP of 5 in n factorial, that is equal to 31 times. Okay, n factorial is not given. Previous question, okay, if you observe factorial is given, you find IGP. Here IGP value is given. In n factorial, IGP of 5 is 31 times. Question is find greatest possible value of 11, means IGP of 11 in n factorial. Find IGP of 11 in n factorial. No specific formulas are there. This is simple observation. Done. Now, according to the question, in n factorial, IGP of 5 is given how much? Here IGP of 5, this is equal to 31 times. Achha, when I start the class, reference is what? Reference is 100 factorial. In 100 factorial, IGP of 5 is how much? Do practice. I am not saying ki do ratta maro. You just remember the thought process, flow, and try to remember the value also. Here IGP of 5 is what? 24 times. Do practice so that you can find this value. Okay, 24. So in 100 factorial, IGP of 5 24 times, and here my desired value is what? Desired value is 31, mean more value. Mean whatever the value of n here is more than 24. Achha, how much I will need here? Desired value is 31 and I have 24. I need 7 more. Okay, 24 by 4, that is equal to how much? 6. If I consider 25% more, 25 factorial, if I observe 125 factorial, approximate value, okay, not the exact value, here I will get what? 30, approx 30 times. IGP of 5 is what? Approx 30 times, but you have to check the value. Here IGP of 5 is what? Just keep on dividing. 125 divided by 5, this is 2. 25, 5 into 5. Again by 5, 5. Again by 5, I will get 1. Done now? If I add, I will get 31 times. So my desired value is what? Here n is equal to how much? 125. N factorial is 125 factorial. This is my desired value. Achha, for 126 factorial also I will get same value. When it will be changed? Now next multiple of 5 is what? Next multiple of 5 is 130 factorial. So in 130 factorial I get 32 times. IGP of 5 is 32 times. Suppose the question is how many value n can take here? Here n can take 5 values. N can take 5 values. 125 factorial, 126 factorial, 127 factorial, 128 factorial, and 129 factorial. Any factorial if you consider, their IGP of 5 is how much? IGP of 5 is 31 times. When it will change? When next multiple of 5 will come. Next multiple means in 130 factorial. Understood this pattern? Okay. Now the question is, here n factorial is how much? N factorial is 125 factorial. Now the question is find IGP of 11. IGP of 11 in n factorial. So 125 divided by 11. 11 into 111. Then what I will do? 15. Done. Again 11 into 1. 11 square is 121. 4 is the remainder. Leave. Again divide by 11. I will get 1. So 12 times. So answer for this question is 12. Answer for this question is 12 times. IGP of 11 in n factorial, it is 12 times. Clear? So if IGP value is given, the first step 1, find the factorial, n factorial, desired value, then solve for the next. Then this is the thought process. Clear? Take this screenshot or note it down. Okay. Okay, solve 2 more questions. Find number of trailing zeros. Once again, trailing zero means what? IGP of 5. And this trailing zero, it is the favorite portion for cat. Okay. Find the number of trailing zero for the following expression. Question is 1 square into 2 cube into 3 to the power 4 up to 53 to the power 54. Solve. Find the number of trailing zero. And who will decide my answer? When question is about number of trailing zero, who will decide my answer? Na IGP of 5. Number of trailing zero, it is same as I.G.P of 5. So in this expression, obviously 2 present more number of times. 2 into 5, that will give me 10, means 1 0. So in this expression 2 present more number of times. So 5 will decide my answer. Acha, if I write in this way, one term will come, that is 5 to the power 6. 5 to the power 6, this is one term. Continue this writing. So 5 to the power 6 means what? Here how many 5 present? 6 times. Similarly, if I write this one, 6 to the power 7, 7 to the power 8 like this, next 5, when I will get next 5? Now 10 to the power 11. 10 to the power 11, 10 means 2 into 5 to the power 11. 2 to the power 11 into 5 to the power 11. The 5 present 11 times. In this way, no need to write each and every value. You just write first 3 elements, because here I am creating one pattern, okay, one series, popular series, okay. So this is 16 times. Similarly, 20 to the power 21, 21 times. But the important one is 25 to the power 26. Here 5 present how much? Acha, 25 means 5 square and power is 26 here. That means 5 present how many times? 52 times. But I write it in this way, 26 times plus 26 times. Because here I am creating a AP. Look, when I write 20 to the power 21, here 21 times. So if you observe the gap is 5. Common difference is 5 everywhere. 20 to the power 21, here 21 times, then 26 times. If I write 52 directly, I can create the AP, okay. Similarly, next important one is 50 to the power 51. So here 50 can be written as 2 into 25 to the power 51, and 25 to the power 51 means 51 plus 51, 102 times. So here I will write 51 times plus 51 times. Now you observe this series. You only focus here. These two I will add separately after finding the answer. So this is in AP. This series, it is in AP. What is the syntax of AP? Structure. Now if first term is A, next term is how much? A plus D. Don't worry, separately we will discuss series and sequence chapter. Done. Common difference is maintained. Then A plus 2D, A plus 3D, and the nth term is A plus n minus 1 into D. This is the nth term or the last term. Done. Now here common difference is what? Second term minus first term. In general, nth term minus n minus 1th term. Okay. And here sum is how much? How to find? N by 2 to A plus n minus 1 into D, or you can say A plus n minus 1 into D. So that is n by 2 first term plus last term. This much required, okay, to solve this question. I am not discussing AP here. Okay, so here if you observe this series, first term is first term, that is 6, and here common difference gap is how much? 5. So if I put, acha, how many terms are there? How to find this term? This is the nth term. Nth term, Tn can be written as A plus n minus 1 into D. How to find this n? N stands for number of term. How to find number of term? Okay. So take this A to this side, last term minus first term, last term minus first term, divided by common difference plus 1. This is the formula. So here number of term in this series, number of term is how much? Number of term, this is 51 minus 6 divided by common difference is 5 plus 1. If I apply the formula, so 45 by 5, 9, 9 plus 1, 10. So how many terms are there? 10 terms are there. So what is the sum here? Sum of this value is 10, that is equal to 10 by 2, that is 5. First term plus last term, that is 57. 7 into 5, 35, carry 3, 25, 3, 28. So here if I add all these values, look at this box only. Okay, so here it will give me 285. And I exclude these two values. If I include this one now, this is 77. So the final answer is, how many zeros are there? So this is 2 carry 1, 15 1 16, 6 carry 1 3, 362 times. So number of trailing zero is, answer for this question is 362. How many zeros are there? 362 zeros are there. In this way you have to handle the series. Who will decide my answer? 5 will decide my answer. Just note it down or take the screenshot. Okay. Next question you write. Find number of trailing zeros. Find total number of trailing zeros in an expression is given 100 to the power 1 into 99 square into 98 cube into 97 to the power 4 up to 1 to the power 100. Okay, find the total number of trailing zeros. Just like the previous question, again create a series here. Acha, number of trailing zero means, again who will decide my answer? Now 5, number of trailing zero, this is called I.G.P of 5. So here 100 can be written as what? This is 25 into 4. That means 25 means 5 square. So when I write 100 to the power 1, number of trailing zeros, or how many 5s are there? 2 5s are there. I write 1 plus 1. Why? Because I am creating one series here. Again AP. Then 95. 95 to the power 6. Achha, 95 can be written as what? 19 into 5 to the power 6. That means 5 present how many times? 5 present 6 times. Then which term I will write? 90 to the power 11. So here it is present 11 times. Then similarly important one is 75. 75 to the power 26. If you observe the power, okay. So here 5 present how many times? 26 times. Okay. 15 into 5 75. So 5 to the power 26. So 5 present 26 times. Similarly, if I write the pattern 50 to the power 51. So 5 present 51 times. Okay, acha, here you can write this is 25 into 3. If I write 25 into 3 here, done. So power is 26. 25 means 5. Acha, 26 plus 26. Done. This is 1 time plus 1 time. And here 51 plus 51. I will consider this series first, then the extra term, just like the previous question, I will add separately, okay, at the end. Similarly, if you write 25 to the power 76, so this is 76 times plus 76 times. Okay, in this way, if I continue, the last one here I will get, it is visible at the end. Okay, 1 second.
Yes.
Okay, here I will write. Okay, 5 to the power 96. So this is 96 times. Then 5 to the power 96. It is not visible. Here I will write after that. Now if you observe this one, this is one AP. So this is 1. Then I will get 6. Next term is 11. And at the end I will get how much? 96. So how many terms are there? Number of term. N stands for number of term. Here number of term is what? Last term minus first term divided by common difference plus 1. So 95 by 5, 19 plus 1, 20. So how many terms are there? 20 terms are there. Okay. Now what is the sum of all these value? 20 terms. S20 is equal to 20 by 2 whole into first term plus last term. So this is equal to 10 into 97, 970. Acha, what are the extra term? 1, 26, 51, 76. If I will add, how much I will get? 12, 2, 14, 4, carry 1. This is 7, 7, 7, 14, 14, 1, 15, 154. So this is 4, 7 plus 5, 12, 2 carry 1, 10, 1, 11. 1, 1, 2, 4 times. The number of trailing zero is how much? 1, 1, 2, 4. It is visible that side, right hand side. 1, 1, 2, 4. Fine, good. Okay, this one, the last. Okay, this is 5 to the power 96. If I continue writing this one, this is 2 to the power 99, 3 to the power 98, 4 to the power 97, 5 to the power 96. So how many 5 present? 5 to the power 96 means 96 times 5 present. So 96 is written, the last term. It is not visible there, just write it down. 1, 6, 11, 26, 25, and at the end, if I continue this, writing this, at the end 96 5s are there. So the series is 1, 6, 11. No need to write each and every value. After 11 dot 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 96. Last term is 96. Find the number of term. Apply the sum formula here, AP formula. Okay, in AP sum is n by 2, first term plus last term. Okay.